All right. So here's the first. Remember, current is the same in series, voltage is the same in parallel. So if you look at this circuit, you're going to see that these two here are in parallel. These two are in parallel with each other, and that is why their current is sharing, because current is going to share in parallel. It is going to be separated, so we are not surprised. The current which starts here, when it gets here, will be split. So we need to know what current we had here. 0.50 amps. This is the current which comes here, gets here, then shares between this. Now, here they say determine the value of the current measured by the ammeter. The ammeter is measuring current. Look at what happens, students. When current gets to a branch, to a node here, there's a special thing called a node where three or more, when current gets to a node is a place where three or more wires meet. It is going to split, okay? That's sign of parallel. And then when they come back together, these wires, the current will rejoin itself again and become what it was. So here it's 0.50 amps again, because it will rejoin itself and become what it was. That's not a problem. So it will be 0.50 all the way here when it gets to the ammeter again. So this is 0.50 amps. Now they say calculate the voltage across the 6 ohm resistor. Now what we know is that circuits are all about you using Ohm's law. You're going to use Ohm's law many times. V is IR. You have two things, either V and R, or V and I, or I and R, and you'll be finding the other one. So here I have I have R. That means I can find V. V is IR, which is 0.50 amps times 6.0 ohms. And if you multiply, you get 3. 3 what? Volts. Okay, so if you can even make it as 3.0 volts, doesn't matter. Volts. Because we used Ohm's law. Now, they will now say, show that the PD across the 20 ohm is 9. So now we come here. Now we come here. They want the voltage here. If the question says show, it wants you to calculate and get the same answer. So it wants you to now calculate the potential difference that will be here. It wants you to calculate the potential difference that will be here. Now, let's talk about it, because this is the most important thing. Let me ask you a question. You see this parallel circuit, the one we have put in red here. These two are in parallel with each other. But these two are in series with this. They're in series with that. Now remember, if they are in series, that means that current is the same. But then voltage is shared. The voltage is shared. Really? Yes. The voltage is shared? Yes. Which voltage? The voltage from the source. The source had 12 volts. Now we just found 3 volts coming here, which means to this other one, there will be 9 volts that come to this other one. So we have 3 volts at the first one. That means we will have 9 volts at the second one. So if they say show that it will be 9 volts, you would say voltage, okay, pair the series one, it will be 12.0 volts minus 3.0 volts, which will give you 9.0 volts. So we have found 9.0 volts. So now we know that the voltage, and remember, voltage is the same in this parallel circuit now, this one. So students, don't refuse to have them mix it up for you. They will mix it up for you to try and confuse you. But we know that these two are in parallel, which means that if they're in parallel, the voltage is the same. So this is 9 volts, and this is also 9 volts, because everywhere it will be 9 volts. Voltage is the same. Now, students, remember, the biggest thing you should always use is Ohm's law. Use Ohm's law, students. We can find I2 now, because we have voltage, we have R. Now we can find I. So remember, V is IR. Here we have I2R. We want to find I2. You say V over R is equal to I. And it will be I2. What is the voltage? 9 volts. What is the R? 20 ohms. So it's 9.0 volts over 20 ohms. This gives I2. What is the answer? What's 9 over 20? Put the answers in the chat. Let's go, let's go, let's go. I want to see the answers in the chat. Let's go, let's go, let's go. Students, 0.45 amps. This is I2. So we know that this is 0.45 amps. Because we used Ohm's law. Because we know how to use Ohm's law. All right. Now, students, let me tell you. Students, don't let me down. We now know that this is 0.50 ohms. What did they ask? Calculate the resistor R. Okay, we go step by step. We go step. So this is 0.45 amps. Now we know that current is shared because this is a parallel circuit. Current is shared. So this 0.50 was shared. You know now that 0.45 went here, so we want to find I1. To get I1, we say 0.50 minus 0.45 amps. This is 0.05 amps. Now, we now know 0.05 amps. And we know that it's 9 volts here because voltage is the same in parallel. So tell me R. How do we find R? Tell me what rule we use, students. If we have I and we have V, how do we find R? What rule should we now use, students? Students, What do we use here? We use Ohm's law. I want to hear you say it. Yes, well done. Ohm's law is your best friend. Once you reason, you should do a bit of reasoning. We did a bit of reasoning. We knew that current is shared here. So we now know how much went down here. So we can find how much went up here. Because we remove from here. We remove from 0.05. 0.5. Because we know we want to find, students, we want to find how much went up here. So we know how much went down here. We remove from 0.5. Okay, that's good. You've used your reasoning. Well done. So you know that now you found 0.05. Well done. And you also know that for potential difference voltage, it's the same everywhere. So we removed because they were in series with this. But when we get to the parallel, these two resistors, this resistor and this, they have the same voltage. So the 9 volts we got is for the top and it's for the bottom. So very good. You now know the top has 9 volts and this. So now use Ohm's law now. You have done reasoning. Now do calculation. How do you do the calculation? Ohm's law again. We want R now, V over I. Which I? I1 is going to be R. What's the voltage? 9 volts over I1, 0.05. What is the resist? What is the answer? What is 9 over 0.05? Put in the chat. Let's go. 180 ohms. So you get 180 ohms. State what is meant by electric field. We talked about it. Region in which a charge experiences a force. It's the region in which a charge or charged particle is going to experience a force. This is going to be the small, easy definition. Now let's move on to the next part. That's back. Here is a negative charge. Draw 4 field lines to show pattern and direction of field due to the negative point. So charges come into negative. The field lines, they come into negative and out of positive. So they'll be like this. Then we come here. It says calculate the charge that flows. So we want Q. Now what do we have here? V, because these are volts. Then here we have the energy E. Oh, really? Yes. So what we remember is that work done, we say that many times. The potential difference, or EMF, is the work done per unit charge, which is the energy over the charge. So we want charge, so we are going to swap. Okay. We want charge, so we're going to swap it with V. So Q comes here, then you have E over V. Now Q will be, what is E? 2.9 times 10 to the power of 8 volts divided by V. No, here. It's 4.5, sorry. Times 10 to the power of 5 megajoules. over 2.9 times 10 to the power 8 volts. Now, mega on its own is times 10 to the power 6. With this, so it'll be 4.5 times 10 to the power 11 joules. Now, we've removed mega. Divided by 2.9 times 10 to the power of 8 volts. Right. Let's go now. What is the answer here? Everybody? You should remember this formula. So calculate questions depend on formulas. So it's on the formulas that we know about this chapter. We'll talk about them just now again. But I gave you in the last lesson. Can somebody tell me what this is? When you are putting this, look how you're gonna punch it. You say open bracket 4.5, then here it is exp. So when you want to say times 10 to the power something, you just say exp. So you say 4.5 exp 11 divided by 2.9 exp 8. What do you get? Please do it. Divided by 2.9 exp 8. What is the answer? Put it in the chat, students. What is the answer? Did you say open bracket 4.5 exp 11 close bracket divided by 2.9 exp 8 close bracket? What do you get? Anita, what do you get? Are you punching? Where are my answers? Clive? One five five one point something coulombs. 1551 coulombs. Surely everybody can punch this. I want answers quick, guys. I want answers quick. Okay. You say 1551 coulombs. So the charge is 1551 coulombs. Okay, is it 0.7 coulombs? The current in a lamp is this. The lamp is switched on for this. So this is I, this is T. Then they say calculate the charge. Q is IT. It's one of the formulas we have put. 2.0 amps times 120 seconds. This is 240 coulombs. So these are easy softball questions. You can do, they depend on the fact that does this student that we are dealing with know the formulas for chapter 4? So I'm going to need to give you formulas. These are easy. We talked about them last week. If you go to the video that I put earlier on in the week, you'll see the formulas that we talked about. You should just know them. The formulas for chapter 4. So this is a question that was testing if you know them. This is easy. Questions that say calculate, they don't need any theory, these ones. No theory at all, just use the formula. Here's a transformer. Describe how an alternating current is going to be produced. We have to talk about changing magnetic field inducing an EMF. But the changing magnetic field will induce an EMF here. We have an EMF here. So the changing magnetic field will be at the secondary coil there. First, we should talk about what happens at the primary side for us to have a changing magnetic field that will cut the coil. So let's talk about it. So you say alternating current in the primary coil. The first one generates a changing magnetic field. An alternating current will generate a changing magnetic field. Please write that. Now, say the iron core links the changing magnetic field to the secondary the iron core links the changing magnetic field to the secondary coil. Okay, then what happens? What happens? The changing magnetic field is cut by the coil by the secondary coil. Is cut by the secondary coil, inducing an EMF into the secondary coil, which produces AC current. You're done. What will make you get marks is you've talked about the main things. You have talked about the main things. That you have an alternating current in the primary coil, which produces a changing magnetic field. Give me a second. You have produced an alternating. Okay, we said we have an AC in the primary coil, which produces a changing magnetic field, and the ion links it to the secondary coil, and the changing magnetic field in the secondary coil is cut by the coil. Don't say cuts the coil, but just say is cut by the coil. It is cut by the coil, and once that happens, an EMF is induced in the coil. Right? And you talk about an AC produced in the secondary, and you can tell them why an AC is produced. An AC is produced because the field is changing, so it will also have a current which changes. Now here they start telling us, hey, turns ratio. This is something which I explained to you many times. When you are given this very important thing, let me write it like this. Right. Turns ratio is equal to primary over secondary. So here we've been told that our turns ratio is 1:20 here. So you can say, what do we use when we told the turns ratio is 1:20? What formula do we have? Because we are now doing calculations. What formula in transformer calculations has number of turns? For transformer calculations, we know that we must know P is VI. For transformer calculations, you must also know that when you say V, this P is VI is important because you end up saying power at the primary is equal to power at the secondary, which means VP IP is equal to VSIS because power is VI. So you should know this. Then you should also know that number of turns of primary over number of turns of secondary is equal to voltage of primary over voltage of secondary. It's exactly the same. Everything is the same. Okay? Over voltage of. And you should also know that you have power loss in transformers, which is found by saying P, the power loss is I squared R. This is the power loss. So if we come here, we say calculate the voltage across. Once we see turns ratio, it has to do with number of turns. So it can only be this formula here, which is number of turns. So you can say number of turns in primary over number of turns in secondary is equal to voltage in primary over voltage in secondary. NP over NS is 1/20. This is equal to what is the voltage of the primary? We don't know. No, we've been told that it's 12 over voltage of secondary. So now we can say, we swap 1/20 and VS. So you now have VSB 12 is now being divided by 1/20. We've swapped them. Okay, that's how you swap. Which is VS is equal to 12 divided by 12 divided by open bracket 1/20. What do you get? Put in the chat, let's see. What do you get when you do this? 12 divided by open bracket 1/20. What is the answer? What's the answer? Please tell me in the chat, students. $240 turns. So you get 240 volts, sorry. So you get 240 volts. Now we've been told the power loss. And we've been told the resistance. So this is power loss. This is the resistance R. Now we know that the power loss is equal to I squared R, which is going to be equal to, here they want the current. So for us to get the current, we take R to the other side. We have power loss divided by R is equal to I squared. Then you take squared to the other side, we have the square root of power loss divided by R being equal to I. What is I? It is the square root of, what is power loss? 1.25 times 10 to the negative 3 watts divided by 0.050 ohms. Then you say square root. So can somebody punch this? Put your square root sign, open bracket, 1.25. When you want to say times 10 to the negative 3, you say exp negative 3. Okay, close bracket. Divided by 0.050. Tell me what you get. Then you do square root. What do you get? This is exp negative 3. What do you get? Put the answer in the chat, students. There are people who have put nothing today. What's going on? Participate, everybody. I want my answers. Thema, what happened? You're no longer putting answers. Lusaka, where is the answer? Letty, I haven't seen an answer from you today. Are you even in the lesson? Put an answer. Calculate, please. Be active. What is the answer, students? I want answers from everybody. Bring the answers. Keep the answers coming in. Tima, can you give me the answer? Okay, so everybody's getting different answers. That's what I was talking about. I want you to practice. This is where we are practicing. Then we'll fix our calculations together. So that's good. I can see the different answers in the chat. Let me make mine and let me see what the answer is. Square root in open bracket 1.25 exp negative 3 close bracket divided by 0.050. Wow. Yes, Aki got it correct. Did you put brackets? Ano? What did you get, Tima? Which one? You mean in the calculation or the answer? Negative 3. Negative 3. 1.25 exp negative 3 in brackets. Then divide by 0.050. What answer are you going to get? Tell me. What's the answer? No, shouldn't be 0.5. Come on, students. Are you putting brackets? Thema, put brackets, please. Do square root. Okay, let me teach you. For those who are not doing it. When you do your square root, open a bracket first for everything which you go in the square root. Then open again. Then say 1.25 exp negative 3. Then close. Then say divided by 0.050. Then close again. And say equal to. So you start with your square root sign. Then you put everything like this. Tell me what answer you should get. Put these brackets like this. Something is wrong because your answers are wrong. Zero point. Yes, 0.158. That's the answer. Well done. Now I love it. Now I'm getting correct answers. This should be your current. 0.158 amps. Okay, you can even say 0.16 amps or 0.158 amps. That's still fine. Well done. Well done now. That's more like it. So that's an easy calculation because we were choosing from these ones. These are the transformer calculations. So, surely you are still young, you're still fresh, your memories are still good. Practice writing the transformer calculation formulas on your own. Huh? Just these for 1, which becomes 2, then there's this 3, then there's this 4. So they are 4. 1, then there's 2, then we have 3 and 4. Try to write them on your own. And you have young minds. You can be able to do it, all of you. So come on now, don't let me down. You're still young, everybody. You should be able to do that in no time. Now, state 2 advantages of higher voltage transmission. We said it allows use. So you can say that current is small. Okay, high voltage transmission. You can say low currents allow for use of thinner, or you can say of cheaper cables or wires. Okay? The other advantage is that there is less energy loss. You can even say because of low current. Because when you have high voltage, it means you have low current. And when you have high voltage, when you have low current, this is what you're going to get. So this is what you are going to do in this one and get maximum marks. If you're answering a physics paper like this, you're getting great marks. Now, I want everybody, I'm going to put the link tonight, go and do October, November 2025, paper 4.1 and paper 4.2 and paper 4.3. I'm going to be checking on all of you. I want my work tomorrow. I want it. So please, October, November last year, physics, paper 4.1, 4.2, and 4.3, you do electricity questions. I want them. Please, everybody, I'm getting your register just now. I want them, please. All of you, even for those who are absent, okay? I want the work, so they're going to have to rewatch this and refresh their knowledge and give it to me. Surely, guys, you should be able to do it. If we're not able to do it, then we're still way behind and we're not doing well. So if you have a question, you're going to call me. You're going to call me and you're going to answer. So, and you're going to ask. I'm going to answer and you're going to ask. So please, everybody, you're not letting me down, okay? I need all of you to perform at your best because I know you can do it. Antonisha, I know you can. Clive, Bondi, use the videos we've been doing. I said, do the questions on electricity and magnetism and submit them by tomorrow night. For that. Let me put the papers on the website. Let me put the papers on the website, and then ask anyone who doesn't have a working account that we fix it.